Hi everyone, welcome back to another devlog update. Actually this one's going to be a combination of a devlog and a bit of a tutorial slash introduction to some of the terminology and tools within Kwyll. This is sort of influenced by the fact that now that I've got a handful of people on Discord who are actively pre-alpha testing, it's highlighted a few issues, not unexpectedly. It's very early. I expected it to cause some problems, and so most of the development I've been doing this week, and the reason I'm running a bit late again on the update, is trying to keep up with the needs of these testers who are pushing it a little bit and finding some of the rougher edges. So having to release fairly frequently to keep them from being blocked. So most of the work has been bug fixes, stability issues and stuff like that. There have been a few minor improvements which I'll go over very briefly now. But one of the things that came up during the discussion on the Discord channel, Discord server, was that while I understand all the terminology and the different aspects and components of Kwyll and how they all link together, I've obviously been working under the assumption that it's obvious, and it is to me because I've been developing it from the outset. To people coming from it cold, it's not always quite so obvious, and at the moment I have no documentation. It's on the plan to put together a website to host some documentation of some form, but nothing there yet. So I thought I'd just take a moment just to go through end to end, explain a little bit about all the different tabs, the different elements that make up a game that you build in Kwyll and how they all work together, and in particular to go over some of the terminology so that everyone understands when I'm talking about objects, what I'm talking about, when I'm talking about sprites, what I'm talking about, and so on and so forth. So without further ado, let's go quickly and have a look at some of the new changes. We switch to the latest version. As I say, mostly actually let's go back very quickly, and I wanted to point something out up here. The logo. I have designed an interim or early test for a logo which I'm reasonably happy with. Love to get some feedback on that, see what you think. I've intentionally made it pixelated because obviously it fits in with the theme. That'll be used everywhere that we need it to be. It's already on the Discord server as the logo. It will be used as the logo for the app and anywhere else that there's any branding. So love to get some feedback on that. If you've got any thoughts or suggestions, do drop something into the comments below, or even better, pop into the Discord channel and make yourself known there. Okay, back to the changes in the editor. So as I say, a lot of it's been around improvements to stability and bug fixes. There's been some changes to collision detection, which I'm not going to go into here. The main things are around workflow improvements to make things a little bit easier for people and a little bit less to try and improve efficiency of various tools, mostly in the rooms editor. So if I go into quickly what I've done in here, so you'll see that this has changed quite a bit. Now before, what I had was there was a mode that you were, so if I create a room very quickly so we got something to work with, there was a mode that the editor operates in a mode based approach. Now what current mode you were in was indicated by what you could see down here. Now as you can see down here, we've got all of the information. We've got the collision information, we've got the current cell, the current tile if there is one selected, and the background and foreground color. So what I've done is I've changed it to be more in line with the sprites, where you had this toolbar over here with a mode selectable there. Now we've got in the toolbar, we've got the mode selectable here, and the modes are: the trowel is for painting tiles, the roller is for painting colours, the barrier is for painting collision information, and this is a new tool which I'll show you in a moment. So if I just quickly create a tile so we've got something to work with, so I can show you how it works. So now you select, before what would happen is as soon as you selected a tile, it would automatically invisibly switch to tile edit mode, and this would change to show just the tile. So now it's a conscious decision to be in tile editing mode. You click on the tool and that tool becomes active, and then you can paint with your selected tile. What I've also introduced as part of this is keyboard shortcuts. Now you won't see me do this, but without clicking I can now go into paint mode and then back to tile mode just by pushing P and T. So it's a little bit easier. You don't have to keep moving the mouse over left and right when you're switching modes while you're designing your your rooms. And the same thing applies to sprites. The sprite editor, I'll show you that in a moment. So it's basically T for tile, P for paint, C will switch into collision mode, and M for the move tool. So if I select a foreground and background color, so if I change it to foreground red, you can see this just updates here, and then switch to paint mode, I can just start painting immediately. Just makes things the flow a little bit easier, a little bit more straightforward, and hopefully a little bit more efficient. It's also clearer what you're working with here. So again, if I want to turn on all of the collisions and switch to collision mode, I can do that without having to come back to the toolbar, or I can click on the toolbar if I want. Now this new tool came about because of another new feature, which maybe I'll show the other new feature first. So you'll see that this has now got a blue border, whereas before in all the other videos it's had a green border. Now actually there is still a green border there, but it's being overridden by the blue border. The green border illustrates the screen limits, so this is 32 characters by 24 characters, 256 by 192, which is standard spectrum size. The blue border represents the window. Now you can change the window size so that you're drawing within a window. This has a number of effects. Obviously it changes the way that the screen is displayed when you're in the actual emulator or on the device, but it also means you're saving some memory, because the sprite system uses memory to keep track of what's happening in the screen that it's responsible for. And if you've got the screen that it's responsible for being the entire screen, then it uses up a maximal amount of memory. But if your game takes part in a smaller window, then reducing the window size to only include that has memory benefits. Now there's no obviously visual way of setting this at the moment, but what you do is you go into this gear icon, which is going to be for project settings, all project settings, and this is the only thing in here at the moment. So you can see we've got a window, and it's currently at 0,0 and 32 wide by 24 high. Now I can change this, and in real time this will change. So it is sort of visual, but I'd like to have a much more interactive way of doing it. So if I wanted to move the window down a little bit so that it's in a bit and down a little, so I'm moving that in and then down, I can do that and then reduce its size so that it remains within the screen. So now you've got the window, which is what will be displayed. Anything outside of this window is invisible. And then you can have things like your console or scores and messages and various other game related things on the outside, and save some space. So that's the reason for the blue rectangle and why it's different to the green rectangle, which is still there to show screen coordinates. I'll paint some more tiles just to show you how this affects the map. So if I just put this in to show the limits of the window, then you'll see when you go to the map, the window, the room is only covers the window size, not the screen size now. So when you place rooms together, it's probably more it's easier to see if I just make the room different, the room change a little bit more dramatic. So now if we go back to the room, we've got a much smaller square room, and you can place the room side by side. Now the navigation that I showed in the last video, where you automatically navigate from room to room, takes into account the window size. So in the room, as you move off the window region, it'll check to see if there's another room over here. So it's not checking to see if you go off screen anymore, it's checking to see if you go out of the window. So that all fits, and the map fits. So your map will be displaying rooms in the size of the window, not in the size of the screen from here on in, and you can place them side by side. Now, getting back to the new tool and the reason for the new tool, so some of the guys testing had actually, before I implemented the window feature, started putting together some screens, some rooms that were smaller than the screen and naturally fitted into a reduced window size. But they designed them, obviously, to fit into the top corner of the screen. And they wanted, on this particular developer or user wanted the window to be in the centre of the screen, which makes more sense. Now, unpainting and repainting all of the tiles to move them across was obviously not particularly appealing. So I very quickly added a new feature here, which you'll have seen in the sprite editor before, which allows you to very quickly just move the room around. So if you want to just shift everything a little, you can do that. At the moment, it only works on the entire room data, but I do have a plan to have some selection tools in, so you can select a region and move a region, so cut and paste, that sort of thing. But for now, it's a handy tool just to be able to move things around. And you'll see it's moving everything. It's moving the colours. If I turn off the collision, it's moving the colours, the tiles, and the collision information all in one. So that's it. New tools on there, I think, and the shortcuts. I'll just very quickly show the shortcuts in action over here. So if I create a new sprite, the shortcuts are paint, A for mask, because I wanted to keep move, M for move, to be common across all editors. So A for mask, P for paint, and M for move. For these two, which are horizontal and vertical, if I just quickly paint something, so you can see, then pressing on H and V will flip immediately. So again, you can use these tools without having to go over to the toolbar if you'd rather keep your mouse in the area of the grid while you're painting. I think that pretty much covers the new things. We've got move, we've got window, shortcuts, and various bug fixes. As I say, most of the time has been spent on bug fixing, so there's not a lot to see there. It's just improvements. Various things have been added that weren't there before, so room objects you can now delete because this wasn't properly hooked up. It is now. There's various other tools in these sub windows that weren't hooked up properly that were discovered by the testers, and I hooked them up and did a new release as quick as I could. So that's the devlog update. I'll just very quickly move on to the onto the other part of this video, which is just going over front to back some of the terminology and the elements that make up a game in Kwyll, so that you can understand when I'm talking either on video or in the Discord or anywhere else. When I'm talking about objects and sprites, you know what I'm talking about, and you can get a feel for how it all fits together. So at the top level you have sprites. Sprites are basically just bitmaps. So you draw your bitmap in the grid. Sprites are part of a sprite sheet, and the game can have multiple sprite sheets. The reason for this is because if you click on the edit button to open the sprite sheet properties, you'll see it has a number of properties that can be unique to each sprite sheet, in particular the size. So the default sprite sheet is 16 by 16, but it can be any combination of width and height in 8 increments of 8. So we can reduce that to 8 and everything adjusts, and this is now an 8 wide by 16 high sprite, and if you create a new one you can draw in there. You can add as many sprite sheets as you like. Obviously each one carries an overhead. Probably wise, just purely from an efficiency perspective, to try and keep all sprites of a similar size in the same sheet if possible. If there's any reason to organise them into different sheets, you can do that, but be aware that there is a small overhead per sprite sheet that happens once per sprite sheet. So if you have 2 or 3 sprite sheets, all 16 by 16, then you're incurring that overhead 3 times instead of just 1. So you can create another sprite sheet and defaults to 8 by 8. So either click on the edit icon or double click and it opens up the properties, and from here we can change it to a much bigger one. And the other property you'll see in there is mask, which defines whether the sprite has a mask layer or not. By default, when you create a new sprite sheet, it doesn't, and this allows you or disallows you to draw the mask. And the masking is basically the sprite can be drawn to the screen in a number of different ways. One of which is masked, which will basically say that. So let me just very quickly draw something in this one because it's simpler. So this one has a mask. So this is the white pixels on here were going to be the color pixels that will be drawn onto the screen. The black pixels are just background color. But if I go into mask mode and I paint a mask like this around, then what will happen is anything in the masked area, which is the checkerboard pattern that I'm just painting now, will show the background through. So when the sprite is drawn to the screen, you'll see the background, whatever it's drawing over, whatever's from the tiles or the room or other sprites, will show through in this area, and only the white pixels will draw over the top. And it's quite common to do things like create a border around, so you get sort of like a black border, very familiar to Spectrum game players, I'm sure, to have this this border around your sprites, so you can distinguish them from the background given the limitations of the system. So that's how masks worked. When you create a sprite sheet with masks in, you have the option to paint objects in mask mode. You don't have to. It's possible to create a sprite and a sprite sheet with a mask but not use the mask in all circumstances. Depends on what you're using it for. And the reason you might do that is because drawing in the other drawing modes, the non-mask modes, is significantly faster. So if you know that you're going to use a sprite that does have a mask in a circumstance where the mask it serves no purpose, it's not ever going to be drawing over the background anywhere. If you're using it in a place in the game that just doesn't have anything in the background, then switching to a different mode for that object is wise. So I think that covers sprite sheets. We've got add and remove sprites here, and this is duplicate sprites, so you can easily create a duplicate of your sprite to work on, which is useful for doing things like different frames of animation. You start with a particular one and then go and modify the frames and sort of reanimate it to do something else. Okay, the tools I've already covered. I think we've got move, which just moves it around. In the sprite editor, it wraps, so you don't lose any data, because there's nothing outside of the sprite editor, unlike the rooms editor. So it will wrap, so you can always get it back. The flip, horizontal and vertical, does the flip on all layers. If there's a mask layer, it'll flip on that as well. So I think that covers all of that. And as I say, sprites, bearing in mind, always are visual only. They're not objects. You can't use them in rooms. You can't drag and drop them into rooms. You have to assign them to an object in order to actually use them in your game. These are just bitmaps, complex bitmaps. So moving on to objects. This is probably one of the most complex editors in the tool. So you have a list of objects, and each object, as you create an object, it pops up a bunch of properties in here. So let's create one very quickly. Starts off unnamed, and you can change the values in here. So we'll call this one object 1. This is where I mentioned about the different drawing types. So by default it will draw load, which is basically writes the pixels and the background pixels over whatever's in the background, so it'll completely wipe it out. So for the 8x8 squares that make up your sprite, this will completely overwrite what's in the background. The OR and XOR will do the equivalent bit masking over what's in the background, so OR with the background or XOR with the background. Again, these should be fairly familiar. I'm not going to go into detail what they do. And the mask one, as I said, will use a mask if there is one. If you've got an object that uses a sprite sheet without a mask, that option won't be available. So I can demonstrate that by just selecting the other sheet here. I haven't got any animation, so that's fine. And the mask one isn't. You can see the mask one isn't available, and that's because the second sheet doesn't have a mask layer. So if you switch that back to main. Now again, you can see there's no visuals here. I'll come back to dynamic in a moment, but there's no visuals here. There's nothing to see. The visual representation of an object is defined by animations, even if it's only a single frame. If you're not animating, you have to have at least one animation with a single frame in order to get a sprite to display as an object. So this is the animation section here, and if we create a new animation, each animation draws one of these layers, so we can create multiple animations. And this section here, so this is the sprite, the animation number, which will change because I'm not happy with the way it works, but for now it's just a simple animation number. This black area here is a preview of the animation, so if you've got multiple frames, this will continually cycle between the frames to show you how your animation will look. And this section over here is where you got the frames, which we have none at the moment. So if I add a frame, it automatically selects that frame. If I choose the sprite now from the sprite list, this is the sprites, all the sprites in the sprite sheet that's assigned to this object, then you'll see it changes to that visual, and that follows through now. So if you go over to here where you've got assets that you can assign to rooms, that initial visual, the first frame of the first animation, will be what's seen here when you're dragging and dropping things. And you can add multiple frames, so that one, because it's got no animation, no sprite in it, you'll see it's flashing now because it's toggling between this frame and this frame, which is blank. So if we select this frame and put our other sprite in there, then we have an animation. And you can add as many frames as you like. Obviously each frame has an overhead, but the system is designed to minimize the cost of this. It's fairly cheap to create multi-frame animations. This button here is for inserting a frame, so if we go to that one and I want to insert a frame, it'll put one just before it, and then we can delete frames as well. And that's just if you decide you wanted to add a little more. So if I wanted this to be a little bit more, a bit smoother, maybe with an interim tween frame there, I can just insert one, draw a new sprite, and adjust the animation. The green indicator is which animation is selected, and that's only relevant at the moment for that button, which deletes the currently selected animation. And I think that's it for animations. I think it's fairly simple. You can have as many different animations as you like, and the logic allows you to switch between animations based on various criteria, which I'll get into in a moment. The last thing on here was the dynamic. Now there's 3 different types of objects that you can use in the game: local, global, and dynamic. Now local are objects that you place, let me just create a room very quickly. Local are objects that you place in the room. So if I drag this object now into the room, it's in this room, it can only exist in this room, and only if this room is the current room displayed in your game will you see that object. As soon as you move to another room via the map or the logic to navigate between rooms, that object will be removed from the system. You can't see it, it's not doing anything, it's not executing any logic or anything, it's gone. Until you come back into the room, and then it'll be placed back in its start position. I'll get to start positions and so on in a moment. The second type of object you have is in the map. So let me just very quickly add something to here so that I can drag a room into the map and see what's going on. So we drag a room in. So we've got rooms, we can drag another one alongside it. Now if we drag an object into here, even though I appear to be putting it in that room, it's not associated with that room. It's a global object. It will exist always. So even if if I'm in this room, you'll see it there. If I'm in this room, it'll still be there, but you just won't be able to see it. Now the typical use for a global object is the player, obviously, because you want the player to be able to transition between rooms. So as he goes into this room, as the player goes into this room, it still exists as a global object. It hasn't disappeared because you're no longer in that room, whereas objects in that room will disappear. So I hope that's fairly clear. And the final type of object is dynamic. Now they're objects that are created at runtime using logic, and they're for things like bullets, projectiles, special effects, that sort of thing. You have a limited number of dynamic objects that you can use in the scene because there is an overhead, and it's an overhead that has to be defined ahead of time for efficiency purposes. So the system for dynamic objects allows you to define per object type how many of that dynamic object can be allocated. It defaults to 0, which means if you try to allocate or you try to spawn using the spawn node an object of this type in the game, it won't happen. It won't allow you to because it's at 0. You can set it to say 5, which means at any time you can have up to 5 of this object dynamically allocated in your game. Any attempt to spawn another object when there's 5 active will fail. And you can then destroy objects, you can kill objects as well, so that frees up another slot. So if you fired 5 bullets, one went off the screen and you had some logic that checked when it went off the screen to destroy the bullet, you've now got an empty slot, you can fire another bullet, for example. And there's a secondary limit which at the moment is fixed, but will be part of the project settings when I get round to putting that in, which limits the total number of dynamic objects at any one time of any type, and that's currently defined as 10. So if you had 3 object types, each with a maximum dynamic of 5, you couldn't have 15 objects, 5 of each. You could only have up to 10 distributed how you like amongst those 3 object types. That limitation will be editable in the project settings when I add it, but obviously that does have a consequence on the size of your game. So those are the object types, 3 different object types. I hope that's fairly clear. The logic, I've already covered this a number of times, so I won't go into too much detail here, but this is basically where the behavior, the activity of your objects is defined, and you define it using the node system, which I'll link to some other videos in the channel that go into a little bit more detail about how the logic works. But basically you're creating triggers which define when the logic that you're connecting to this trigger gets executed. At the moment there's only 2, which is always and initialize. Initialize will happen once when the object is created. So in the case of a local object, it will happen every time you enter the room as a part of an initialization because the object is being recreated. For a global object, it will happen once when the game starts, and for a dynamic object, it will happen every time an object of that type is spawned. Always is just runs every frame. So again, only if that object is visible and active, and so therefore if an object is local to a room and that room is not the current room, then the always won't execute. And then what you do is you just basically add nodes and connect them with these wires. And there's 2 types of wires, well 2 types, but subtypes within the second type. So the double arrow you see on the always and on some nodes, not all, is execution flow. So basically as the engine runs, it'll come in here and it'll follow this through to the next execution flow, and if there's something else following on here, so we can add a int comparison here and flow through, so it'll do whatever it needs to do in here and then flow on to the next part of the logic. And some of them will have multiple ones, so multiple output flows. So the integer compare will do a comparison between the 2 values that it's provided with, and if the comparison is true, then it will follow that path. If it's false, then it will follow this path. So you can have multiple flows, and that's how you get more complex logic. The other type of connection is the green and blue, which are data flow. So if I do a get, for example, which allows you to get a variable from an object, there's no variables defined on this object at the moment, then you can see you can connect green to green. All variables at this point are integer variables. So I'll just quickly cover variables. So if we go over to here, we've got a list of variables on the object and you can create new ones. So if we create a temp, you'll notice that changed immediately. So now I can get the variable temp, and that goes into X, and we can check to see if X, basically what we're doing here is we're setting the X position to the value of temp, whatever that might be, and that can be set using other nodes and so on. The other type of data flow is the blue line. This is for object references. So an object reference is excuse me, a reference to an object of a particular type, either globally, locally, or dynamically. So every time you add a new object to the room, this is not an object, this is an object reference. So this is an object reference, and it has a bunch of data associated with it, part of which is pointing to the object type, which is defined here. So typically when you're working in logic, you're working on the object that the logic is assigned to. So when you're moving the object, you're moving this object. But there are some things, sometimes when you want to be able to do things on other objects. An example is when you move, what it'll do is it'll move to the X and Y position you've asked to move to, and at the same time it will check to see if it's collided with any other objects. And then what you can do is you can do set object variable, for example, so that if there's a collision, this flow will be triggered. So if the move results in a collision, then it will follow through this flow first, and what you get out of here is the object that you collided with. So if you want to set a variable on that object, then you connect that to the ref, and the data here changes now, because it doesn't know, while we're editing the code, what the object type is. It only knows it at runtime when the collision happens. It could be any object. So here you have to say, I want to set the variable, but only if it's of object type something. So if we had more than one object type, they would list here. So you could have an enemy, for example, and you could say if you've collided with an enemy, you select enemy there, then set the variable hit on that enemy to 1, for example. So that allows you to communicate between objects, and there are a number of other places where these references are provided by different things, and that'll grow as we get more nodes. But those are the basic two types of data flow. Green is variables or numbers, integer values, and blue are object references, and you should only be able to connect them appropriately. So that defines, or just really covers the basics of what logic looks like and how it works. At the moment, the only place you can use logic is on objects, but you'll see there's a logic tab up here at the top level. That'll be for global logic. So the idea would be you could add some logic graphs in here that happen whenever you're starting the game, or at every frame in the game, irrespective of which room you're in, and have access to all sorts of other things that you wouldn't have access to at the object level. But that's not there yet. And the idea also would be to be able to apply logic at the room level, which also isn't there but is catered for. I think that covers objects. As I said, objects was always going to be the most complex one. They're the most important part of any game that you create in Kwyll. So they have a lot of complexity and a lot of areas to cover. Rooms we've already touched on a bit. So a room is just a background map of tiles and a bunch of objects. Optionally, they don't have to be objects in a room. The room can be just purely background tiles. The map, which is what you draw over here, consists of 3 different things at the moment. Tiles, so you have a tile sheet here, which is very similar to the sprite sheet, except there's only one tile sheet at the moment in the game, so it's shared across all rooms, and you can define and draw as many different tiles as you like, and then paint those tiles to create your map. Now you'll notice that all the tiles, much like the sprites, are white on black by default. That's intentionally. In order to change the colour, then you you work in the second type of thing that happens on a map, which is attributes or colour. So down here you've got some indicators that show what you're working with, what your tool's working with at the moment. So it's currently red foreground colour, black background colour. The currently selected tile is this one, and the collision information is full collision. So in order to paint colour, then you choose the colour that you're interested in. So let's have blue background and green foreground. You select the paint tool and just paint your colours. This allows you to reuse tiles without having to have copies of the tiles for different colours. So if I wanted all of those to be green on blue and all of the others to be, or these ones to be purple on blue, I can do that, and I don't need to have multiple copies of the tile because the colour information is completely separate from the bitmaps. And again, I can switch to red for these ones. You'll have noticed when I missed there that there was a white outline, and the reason for that is all the information that gets exported from the game obviously has an impact on the overall size of the game, and when you're working on a limited platform like the Spectrum, you want to be very cautious and conscious of data that you're exporting. So the reason this is outlined in white is if I had black as my background colour and I painted that, if there was no white border on there, there's no way of knowing that I've actually put in an attribute there of red ink on a black background because there's no tile. Now it may be that you want to do that. You may want to have, for some reason, attributes painted on certain tiles that you just can't see, but it's important to be aware that it's there because this will be exported as attribute data, which has a cost. So if you ever notice that there are some cells or some tiles that have got these white backgrounds and you weren't expecting them to be, you can just wipe them out and that'll save on the export. And the third element that you paint on the map is the collision detection. Now that's again another separate layer done at the tile level, and it's using this tool here to distinguish between up, down, left and right. And the reason for that is, for example, if you were designing a platformer, you might want your platforms to be solid when you're falling down onto them, but make it possible to jump up through a platform. A lot of platformers use that mechanic. So what you can do there is you can decide that for each cell that you paint this collision information with, it'll only block movement from above. It'll allow movement from left, right or below. And you can see down here this is indicated as a red bar on the top half, and you can have any combination. So we can have a platform maybe block from, let's turn the collision back on so we can see what we're doing, block from left and up, and then for the rest of the platform up only, and then on the last one right and up, so which means you can jump up from underneath. You can't enter the platform for this side or this side, and you can't go through the platform from the top. So now you've got three sets of information on here. You've got the tiles themselves, you've got the colours, and you've got the collision information. Currently you can switch off the tiles, which switches off the attributes as well, and or the collision information just to see what you're working with. So if you wanted to see more clearly what your collision is set up as, you can just turn off the tiles. And similarly, if the collision information, the overlaid red markers are getting in your way while you're designing the look of your room, you can just turn them off while you're working. So it's just a convenience. I covered earlier in the video the new tool to move, so that's just like the sprite one, just allows you to move things around, move the whole thing around. This button here is for bright, so anyone who knows the Spectrum will know that you have these 8 colours plus bright, and there's flash, but I'm not using flash at the moment. So this allows you, if you switch that on, it switches on bright, so now the red ink colour will be painted with bright If I actually put the blue background back on, you'll see the difference. It's very, very slight, but there is a difference on here. I've chosen the brightness to try and match as close as possible what actually happens on the spectrum. So it is a subtle difference, but it is on the spectrum anyway. So that allows you to do brightness on and off on an attribute as well. I've already covered dragging and dropping objects and local objects. The tile editor is very similar to the sprite editor, so plus and minus to add and remove tiles, and duplicate if you wanted to create a copy to modify. Up here we've got a list of rooms, so if you had another room you can swap between the rooms and start designing your other rooms, and the currently selected room updates this list of objects in the room, so you can select the object, you can move it around on here, but also you've got a bunch of properties that are associated with this object reference. If you remember, I mentioned references. Object references are references to a particular object type, and they have some data per reference, and what they have is a name, but they have also a position, which in the case of a local object is the position within the room, and they have a couple of flags. So collide will enable collision with other objects. If that flag is not set, then the object will just ignore collisions with other objects. And collide the background, which means when you move this object using the logic, it will collide and prevent interpenetration on cells that have collision information on. So obviously critical for the player, and there are probably other game elements that you want to collide with the background. And then below here we have a list of the variables that you defined on the object logic. So if you go back to the object again very briefly and go to our logic, you'll see for this object type, object 1, we defined one variable, temp. So when you create an instance of this object, you can define what the values of those variables are for this instance. The variables are unique per reference. So if you have temp, or if you have direction or position or shooting or whatever your variables are, they will be unique to each reference. If you create 5 of these objects, each variable on each one is unique to that particular object. It won't, if I change it on one, it won't modify the values on the other. But the logic, when it executes the logic, it will see the variable on the instance, on the reference, not on the object definition. I hope that makes some sense. If you need me to clarify any of these points, please do drop a comment in the comments below, or pop over to the Discord, and I'll happily clarify some of these. I think that covers most of what we have in the rooms editor, and then the last one of any complexity is the map editor. So this is where you define what your overall game looks like in terms of rooms connecting to rooms. So we've only got one room type that's got any. Let's draw another. Actually, undo that. So this is painting in the wrong mode. I'm meant to be in tile mode, and let's just draw some tiles on this one so we got something to see in the map. So now if you go to the map, we've got two rooms here, and this assets list will grow to show all of the rooms. So I could drag a new room in and just drop it in underneath. Now the positioning between these on the map is critical because of the new navigation system that came in only a couple of updates ago. So if an object, a global object, moves off or outside of the window or outside of the room in a particular direction, the first thing it will do is check to see if there's another room connected in that direction. So if this is the player, for example, and we move him off here, as soon as it moves off that outside of the window, it will check to see if there's another room here, and that room will then become the current room and be redrawn, and the player will appear in that room. So navigation is just taken care of by the map now. There will be some logic that allows you to transport to other rooms. So There are some cases where the map doesn't make sense, and you'll want some rooms that are not connected. So, for example, this one, the way that I've designed this is coincidentally ideally suited to an interior. So you may have a house in here. This could be a forest area, and you could have a house in here. You walk into the door and it takes you to a room. And what you typically do there is just move this one off here so that it's not connected in the map, but it's a separate room. And then you'd have some logic in here that detects the collision with the door and transports you directly to that room. And then there might be another door here which transports you back to the forest. So you've got two types of navigation. You've got simple navigation, which just happens within the map. You don't have to think about it. And then you've got the navigation between scene types, if you like, where you're going from. You're navigating directly to a room consciously or implicitly, explicitly. I mentioned you've also got global objects in here. So any objects you place in the map, anywhere you place them, will be global objects. They don't have to be in a room, they can be anywhere. We can place them over here in this room or outside of a room or whatever. Not sure why you do that, but you can. They will exist and run all of their code all the time because they're global objects. So be wary of that. Don't overuse them because they'll have not only a memory overhead but an execution, a runtime overhead during gameplay. I think that's all in the map. Logic, as I said, isn't implemented at the top level, and the last one is preview. The preview is a simulator. I've covered it in another video, so I won't go into any details here, but it basically allows you to play your game live in the editor as a rough simulation of what it would look like on device. It's not an emulator by any stretch of the imagination. It doesn't emulate any Spectrum features. It's really for testing the logic and the gameplay and how it all works, and it'll do its best to try and keep as close as reasonably possible to what it'll look like on device. For example, you don't get color clash, you don't get any color issues in the simulator, but you will be able to check all of your logic, and this area gives you a bunch of debug information. So I won't go into that now because I've already covered that in other videos. I think that covers most of all of the terminology and understanding how the different parts fit together. In terms of the editor, I've already covered. We've got project settings, which currently only has the window. We'll have more as we go on. The toolbar buttons are new, which just wipes out what you're working on and starts a new project. No warning, so be careful. Save, load, export, which will do a full export. It'll export to the C code for the Spectrum, and it'll run the compiler if you've got a compiler toolchain installed. So if you open that up, first thing you do is check to see if you've got a toolchain installed, which I do, and set a target directory. You just choose a folder and then click export. It'll do everything and build you a TAP file that can be loaded into an emulator. This last one is a useful tool. I'm not sure if it'll stick around forever. If it does, it might be more hidden because it's more for my use than anything, but it basically does a partial export. It'll export the C code for everything and then display it in a window for me to have a look at, or for anyone to have a look at and see what code is generated. Might be useful in the future to do things like optimization or check to see whether it's exporting what you expect, but probably not used by most people. So I think that covers everything. Hopefully that's useful as like an introduction, not a tutorial by any stretch, but an introduction to some of the terminology and some of the information that you need to understand in order to make use of Kwyll. So for those people who are already subscribers on Coffee and have access to the alpha, pre-alpha, hopefully that'll help clarify some points of confusion if there were any. Could be a useful reference in the future, and I will be working on some documentation to support it in the future. And that's it for today, I think. So again, if anyone else is interested in doing some early testing and playing with this, some of the things that the guys are implementing on the Discord channel do look very impressive. I'm very pleased that it's being used in anger finally, and producing some very interesting looking stuff. So if you wanted to take part in that, do pop over to the Coffee channel. The silver subscription will get you automatic inclusion in the pre-alpha, early pre-alpha, so you'll get access to the Windows and Mac, currently only Windows and Mac alpha versions, which at the moment are being released a few times a week, really in quick responses where I can to issues, and to include new updates. So you're getting fairly regular updates on there, and you have access to a specific channel on the Discord where I will respond much more quickly to issues or requests. So if you're interested in taking part, pop over to the Coffee. If not, by all means join the Discord anyway, and take part in the discussion. Any ideas and suggestions always welcome, and I'll see you next time. Don't forget to subscribe and hit like if you like it, and hit the bell if you want to be notified when I get round to uploading new content. Thank you. Bye bye.